Hi guys, today we are going to start to what the deep analyzing of the class structure in C++ programming language. Okay, and so as you remember, we need to add a new file in here, main.cpp, in order to compile our program in the C++ programming language. And so also we need to also add the terminal section in here in order to compile our program. Okay. And so today we can move forward to the example session. Okay, example 1. And so as always we do, we need to add the iostream in here, and so we need to add the namespace std with the main function of this body. This is the indicating to what the execution point of our algorithm in the C or C++ programming language. Okay. And so in the previous lesson we can create we have learned how to create a new type of definition in CPP programming language. Okay. And so if I run this code in here with the selection of the C++ compiler, g++.executable file in here, and so we can build our program like this one. Okay. And so launch and task JSON file are created at that position, and so the class A has a correct syntax in CPP programming language. And so how can we create an object with the kind of with the type of the class A? We can use the A section in here with the definition of new objects. Okay. And so these are the object or variable with the terms of the class A. Okay. And so if I run this code again, and then the terminal has give no error at this position. Okay. And so in order to understand the class structure in CPP programming language, we should create the two terms or two conditions in here. One of them is the structure or structural elements of the class, and the other things is that the functioning or functions of the class structure. Okay. In CPP programming language we have this kind of class structure definition. Okay. And so we need to use the class keywords in here with the definition of the new type of name, and so we open and close parentheses with the dot comma operator. Okay. But the structure of class in CPP programming language consisted of the three sections with the name of the private section, public section, and protected section. Okay. These are familiar in the C programming language, but with the different usages. Okay. Because the private, public, and protected are used in order to hide or show the class variables, which means that if we give the private notation in here or public notation in here with this syntax and protected notation in here, we can divide the class A to the three parts. Okay. But how can we use these keywords in a functional way? Suppose that we have a private section in here, integer A private or integer A variable at this position, and so we can define the integer B value at the public section, and so we can define the integer C in the protected section. Okay. It's coming from the basic syntax of the CPP programming language. And so if I run this code, you can see that there is no syntax error. But what's the difference between the usage of the private or either the public or either the protected section? And so if I have the new object variable in the main function body, and so I can use this variable by using the dot operator, but the only element is showing in the main function body is the B section. Okay, but the class A also has the A and C variable in itself. And so what did tell us? Did tell us, or it did tell us, or it will tell us, or it means that the integer B within a public section is open or can be reachable in the main function body. And so new object.b can be assignable in the main function body, but the private section cannot be reachable in the main function body. And so you can ask me that how can we use the integer a function in here? I can show you that in the previous section or lesson we have talked about the class possess the functions, okay? And which means that we can create the function body at this time. And so for example, void print great guys, like this one, okay? And so these are main function body or the function name, and so we can write it into the class or the A class, okay? And so how can we use the private section? By using this function body. In the class we can reach the A variable like this one, okay? And so if I run this code, and there is no syntax error, but the A is reachable to where the print guys function. And so we can say that private section can be reachable, can only be reachable in class definition, okay? And so public section or section can reachable in anywhere in the programs, okay? Protected directly related to the inheritance usage, and so only derived and class section can be reachable by using the protected section, okay? And so this is irrelevant for our study because you don't know how to use the inheritance structure in the CPP programming language, and so we can delete it at this time, okay? But the default definition of the protect class is only relates to inheritance, and so the only derived in class section or class function can reach this C variable, okay? And so what about this? If we have the function body under the public section, and so we can also call the print guys function, okay? And so we can write it down as the A is equal to the A and Lee, and so see out the Berkem and Ali Ihsan are great guy because these are quiet guy, okay? And so if I run this code and build this code, and then A is given or return value of the 6, but we can also have a Berkem and Ali Ihsan are great guys on the terminal section, okay? But But if we move to this print guy function to the private section, and so if I run this code, and then Berkem and Ali, our great guys, is also showing, but this is a compiler error, because if we rerun this code, and so problems is that function a print great guys is inaccessible, or it means that the class notation cannot give a permission to obtain or to use this function body, because it's included under the section of the private section. Okay, and so what did it tell us? It tells us that if we have a variable that only used in the class structure or class functions or class variables, and so we can keep it in the private section. But if we have a functions or variables in the class notation, and so we should define it in the under the public section in order to use in the main function body. Okay, this is the main rule of the structure and functions of the class notations. Okay, these are the first example related to the what? Related to the class structure. Okay, this is the example 1, and so we can move to the example 2. Okay, and so we should create the new example session at this time, and so return 0 value is given in here. Okay, class A also is defined, and so we have learned that we should drive the private and public section in this class notation, and so if we rerun this code, and then there is no syntax error, and so as you mentioned that the whole class has a functions, which means that the void print hello world function body with the name of the cout hello guys in here. Okay, and so if I create a and so a prints hello world can be called by using these code notations, and so okay, I'm sorry, and leave. And so if I run this code, and then the hello guys is printed on the terminal sections. Okay, but if I move this code in the private section, and then there is syntax error at this position. Okay, and so these are the main function body, and we can split our public section, the general functions in here like this one, and so general function like this one. Okay, and then what? Every class or class variable in CPP programming language by calling the constructor operation. And so if you wanna do the creating the class variable like the A in this notation or in our examples, and so there always be a constructive object or constructive function like this one. In the constructor definition, we can use the A or the name of this class with the open and close parentheses. And so if I push this class notation, and so this is our basic constructor. Okay, this is the constructive object in order to keep or store the space in the RAM locations. Okay, and so if I create the A, or if I define the A variable with the type of the A class, and so this function is automatically calling by the what? By the compilers. Okay, and so this is used to what? To store the space or the constructor object at every creation of this A class. Okay, and so another parameters is that the tilde operator gives us, with the name of this class, is the destructive objects. Okay, because destructor. Okay, and so this is the establishing or the constructor object of the any variable with the type of the A class, and so destructor is the destructive object in order to remove or the lost every space in the RAM location. Or so if you want to destroy the R variable in the main function body, we should call the destructor, but the compiler also calls automatically in every iteration of your codes. Okay, and so how can I prove it? If we have the A constructor objects in here, like this one, A default constructor can be written on the terminal section. And so if I have called the destructor in automatically, and so the destructor is also called by the programs. Okay, and so destructor, A destructor. Okay, and this should be given at this position. And so if I define the A variable at this time, and then I expect that this A constructor is called, and then the program returns 0, and so the every space which stored in the RAM storage should be given to the computers, and so this destructor should also be called at the end of these programs. Okay, and so if I rerun this code, and then the A default constructor is calling at the beginning of this code, because A print hello world can be called at this time, and so the A default constructor is called at this position. Okay, default constructor is called, and so the print hello world or hello guys are written at this position, and so after that every return value of the 0, which means that the success value is obtained from the main code, and so the destructor of A is called in order to what? In order to give the some RAM location to the computers as a free means. Okay, and so we can know that now that every class has the default constructor and destructor, and so if we want to don't write this constructor and destructor objects in here, the class automatically writes that. Okay, but if we write it down, and so we can push the some main function body or the some operation in order to what? In order to activate any function like this one, the printing the A default constructor can be called in the constructor object. And so if I run this code, and so a default constructor is given at this position without calling a function, because the creation of A is the necessary condition to call the constructive objects, and so the destruction of the A or removing the A variable in the main function body is called by the destructive objects, whatever you can use or not. Okay, this is the basic definition of the constructive and destructive object in C++ programming language. Okay, and so these are the second examples session in our lesson, and so we can move to the specific class. Okay, include iostream and using namespace std and int main body. Okay, and then what? Suppose that we have a rectangle class in CPP programming language, and so we suppose that we want to create a rectangle with the dimension of the height and width value, and so in the program we want to calculate the area of the rectangle by using the class variables. Okay, and firstly we need to define the structure of this class, private section and public section. Okay, and so we can write it down, the rectangle constructor in here, and so rectangle variable is created or is constructed. Okay, we can warn the user by using these terms. This also a constructor. Okay, and also we can use the tilde operator at this time, and so rectangle tilde in the given the form of the rectangle variable is destructed. Okay, and so if we create the rectangle variable with the definition of the rect1 variable, and so if I run this code, and rectangle variable is constructed and rectangle variable is destructed. Okay, and so how can we use the rectangle function in here? By using or creating the only variable definition at this time. Suppose that we have a two variable, private variable in here, like this one, the double height value and double the width value. Okay, and so if we have this kind of height and width value at this time, and so if we can write the width value like this one, dot 6 in here, and rect1 height value 7.3 values in here, and so if I run this code, there was a syntax error because the double rectangle width is private within this context, or the compiler tells us that you cannot reach these variables because of this is included in the private section. Okay, and so how can we update the height and width value at this time? Okay, the rectangle variable is constructed in here. If I call the rectangle constructor, which means that the rectangle, if the rectangle is created, this is automatically called by the what? By the compiler or the programs. And so if we have this kind of information in here, like this one, and so we can ask the user to what? Give height and width value in here. Okay, and cin can be used with the what? The height value and width value. Okay, and so we can print the whole the height and width value, height, okay, and so width and width, okay, and lee. And so if I run this code at this time, I can use, or I have created the rectangle 1 variable, but the compiler tells us, the program tells us, give height and width value at this time. Okay, 5.6 and 7.8. And so if I push the enter button, the height is set to the 5.6, width is set to the 7.8. Okay, but I cannot use any function to call this constructor, but every parameters is built by creating these functions. This is a powerful feature of using the class structure in C programming language or C++ programming language, because every variables is created with with this notation, and so the rectangle parameters can be set by creating only using these notations. Otherwise, we should move this height and width value into the public session, and so we can set the rect1 value height blah blah blah, rectangle 1 width blah blah blah, and so we can move, or we can try to create a complex structure in here. But if I use the class notation with the constructor object or constructive object, and so every variable height and width value is or can be filled by using these rectangle objects. Okay? And so if we have this kind of rectangle function at this time, we can build some general functions in here, like this one, general functions, and so we can call the void calculate area of rectangle, which means that the calculate of area of rectangle gives us the double area parameters can be set with the height times width value. Okay, and so in the cout section, the area of rectangle is equal to the area and length. Okay, and so rectangle 1 calculate area of rectangle can be called by using these notations. Okay, and so if I call this function body, a rectangle variable is constructed, and so give height and width value. For example, 5.0, 6.0. The result is equal to the 30. And so height value 5, width value 6, and area of a rect is equal to the 30 value. Okay, and so is also the rectangle variable is destructed at this time. Okay, and what about our other conditions? The rectangle rect 2 can be given at this time, and so rectangle 2 calculate area of rectangle can be called in the main function body. And this is so easy. If we have the rectangle class with the definition of the height and width value, we can also use every function and every calculation of the area by creating the one variable. This is the main purpose of the object-oriented notation. If we have a class definition of class variables, and so we can use every functions and every variables within the context of the class notation. In this case, the rectangle possesses the height and width value, and specific function can be called by using the variable of the rect2 or rect1. This is so powerful, guys. Okay? And this is necessary in order to create a more complex programming techniques. And so, if I run this code again, and height and width value 2 times 0, 4 times 2, and so height 2, width 4 times 2 is equal to the 8.4. Okay, and so in the rectangle 2 sections at this time, and so 11.4 and 22.8, and so the area of the rect in the second condition 258.78. Okay, and so every destructor is called at the end of this code, or the return value of the 0 is called. Okay, and then this is so easy. If we have the whole definition of the functions and variable in the context of the class of rectangle. Okay, this is so powerful, and constructive object and destructive object can be used in CPP programming language in order to solve the easy way to problems. Okay, this is a simple definition of the class usage in CPP programming language. Okay, and so these are the third example in here. And then what we have also some specific features to be used what the constructive objects. And what about this? In the next sessions we will talk about it. Okay, and also include the IO stream should be add with the using namespace std parameters int main and return 0. Okay, and so class rectangle is also given at this time with the definition of the public section and private section. Okay, and so another feature of the using of the class is given by the constructor overloading mechanism. Okay, this is the rectangle, and so we have also a rectangle destructive mechanism in here, like this one, the cout default constructor at this position, and so cout destructor in here. Okay, in the basic definition of the rectangle class, rect1 is calling with this notation, and so we have the default constructor and destructor in here, because at the beginning of this code this function is calling, and so at the end of this code this tilde rectangle or destructive objects is calling. Okay, but in the CPP programming language we can create many constructor like this one, the string s, and so we can also give the string name in here like this one. Okay, and so we can also need to add the string include at this time, and so the name can be equalized with with s variables. Okay, and so cout the name of rectangle is that the name parameters. Okay, but in the default case we can also, as the default can be assigned to the name, and so the default constructor with the name of rectangle is equal to the name also given in here. Okay, and so this statement also given the string constructor in here. Okay, and so if I run this code and then the default constructor is calling with the name of the default value, but the destructor is also called. Okay, but the rectangle rect2 can be defined by the set string s variable like this one. This is the Berkem rectangle. Okay, and so if I run this code and then the default constructor is calling for the default variable, or this function is called because there is no argumentative parameters in the definition of the rect 1. But in the rect 2, we can give the specific name or string characters in order to fill the string name variable in the class rectangle. And so the string constructor is called by now, okay? And so this constructor uses the default constructor, but this constructor uses the string constructor, okay? And so this rectangle name is what is equal to the Berkem. The other is default, but the destructor is the same way or same called by this function notation. And you should know that the destructor cannot be overloaded in this language because the destructor destroyed everything related to this class or this function possessing this class, okay? And then what? We can name or we can use the many different constructors in here, like this one. If we have the double variable with the height value and double variable with the width value in here, and so we can build the rectangle class with the parameter of the string s, and so the double height, double w, okay? These are the basic parameters, and so the name can be assigned to the s, and so the height value assigned to the hash, and width value is assigned to the v, and so the cout string plus height plus width constructor can be given at this position, and so the cout, the name of rectangle, can be given by the name and li, okay? And so we can also use the rectangle class rect3 with the name of the Ali San rectangle, and so double height 4.0 5.0, okay? And so if I call this program and then default constructor with the name of the default, string constructor with the name of the Berkem, and string height width constructor with the name of Ali San is called, okay? But additionally, height and width value are updated by using these constructor notations, okay? And so if I use the calculation of the area in this code, we can build also the void calculate area of rectangle function can be called at this time, okay? And cout height and width value is equal to the what? The height and width can be given at this time, and so the cout value area of the what, the name rectangle, is the what, the height times width, okay, and li. And so this function can be called in this rectangle constructor, okay? And then what? If I run this code and so default constructor is called for the rect1 and the name of this default, because there is no name with the parameter argumentative object notations, okay? And so the string constructor is called in here with the Berkem notation, and so the string height and width constructor is called for the Ali San rectangle, and so the height and width value 4 and 5, because this constructor possesses the calculate area of rectangle in the function calling mode, and so the area of the Ali San rectangle is equal to the what? The 20, okay? This is the basic definition of the constructor overloading mechanism in C++. programming language. Okay, plus void constructor. We can also call the calculate area rectangle function in the other constructors. Okay, like this one, string s, or like this one. But if I call these constructors, if I rerun this code, and then the name of rectangle default is given for the rect1, but the height and width value is equal to the what 1.70 plus e minus 307, and so this is the garbage value of our values. Okay, and so the area of rectangle, default rectangle, is equal to the 0, and so the string constructor or the name of constructor Berkem is equal to the what, the height and width value with the definition of the 6 times the e, or 10 over 259, and so the multiplication of these two variables gives us the infinity value. But this is also a what, the garbage value. Okay, and so the string height width constructor is equal to what, the name of the Alisan, and so the area of Alisan is correctly calculated by the programs. Okay, and so this is the definition of the usage of the what, the constructor overloading mechanism in CPP programming language. And so how can we update the rect1 value even if the private section possesses the height and width value? We can use the function to update this notation, void update height value in here, like this one, update height. And so double hash, and height value is set to the hash. Okay, void update width value, double w, and so width value is equal to the w. And so the calculation of the area of rectangle can be dismissed from these parts because we don't have the any height and width value in here, like this one. And so if the rectangle 1 is possessed this notation, and rect1 update height value with the what, the 5 times that, and so rect update width value 4.0, and rect1 calculate area of this function can be called. Okay, and the second notation is also built this kind of information. But in the third case, the default constructor or the string height width constructor possesses this 4.0 and 5.0 values, and so we don't need to use this update height and width value in here. Okay, and so if I run this code and then default constructor is called for the what, the rect1, and the name of this the default. Okay, height and width value is equal to the what, the 5 and 4, because the update value height and width is set. Okay, and so the calculate of area of rectangle is called by the program, and so the default rectangle area is equal to 20. Okay, and so in the second case the string constructor is called because Berkem is given to the rect2, and so the constructor overloading mechanism is applied on this code. And then what, the update height and width is called because the update height and width public, but these public functions can reach the height value even if in the section of the private section, because this function possesses the class notation or the class structure within the class structure. Okay, and so the update width and height is called, and then we can calculate the area of rectangle by calling the calculate area of rectangle function. Okay, and so this is also equal to the 20 value. But in the third case we have another constructor with the name of the what, the string parameters alisan, and so width value and height values. Okay, and so this rect function is also has the possessed the calculate area of rectangular function calling, and then this is created the automatically calculation of the what, the area of this code. Okay, these are the basic examples of the usage of the constructor overloading mechanisms. Okay, this is all, guys. In this lesson we have talked about how you can use or drive the constructor or destructive notation, and so we have looked at the structure of the class mechanism with the name of the what, the public and private section. I hope you have learned everything about what I'm saying in this lesson, and so have a nice day.